Hello all, we are team VrudhaRakshak consisting of myself, Sumit Mukesh Khodke, Swastik Bhosle, Aryan Rajadokre, Lakshman Mane, final year BTech students studying in computer science and engineering at Karmavir Bhavra Patil College of Engineering, Satar, Maharashtra. Under the guidance of Professor Shabina Modi ma'am, we have developed a project titled Wearable Sensor Integrated with Artificial Intelligence for Fall Prevention in Elderly People. Okay, so project overview. Falls are leading causes of injury and disability, especially among elderly individuals. The fear of falling often results in reducing mobility, increased dependency, and a decrease in overall quality of life. Our project addresses this issue by developing a wearable device that leverages sensors and artificial intelligence to detect and prevent falls in real time. This device can immediately alert both the user and their caregivers, helping to provide prompt assistance and reduce fall related risk. So let's look at our system implementation. Uh, let's take a clear look at the core components and technologies used in our project. We have designed a product which will be helpful to an elderly person in their day-to-day life. Now we will directly show you how our product will look. So we will show you how our project looks and how we have implemented the project. So this is the heart rate module, which is max 300. Okay, so it is placed outside the system so that it is easily contact in the elderly person's body and skin. Thereafter, once we open the system, we can look inside. So firstly, this is a battery pack. It is rechargeable power battery pack. Thereafter, very main thing is that ESP32, that is a microcontroller and processor which collects the data from the sensors and sends it to the Firebase database. Thereafter, it works on Wi-Fi or Bluetooth, and it can easily connect it with your mobile application. Thereafter, this is a MPU 6050. MPU 6050 is a module which detects the latitude and longitude of any object. For example, if this object entire system is moving, so it can detect the latitude and longitude of the system. Thereafter, this is connected to this module and this sends the data to the GPS module. Once the GPS module gets the signal from the latitude and longitude that fall is detected, it directly detects the location, for example, which are the map coordinates of the location that user is present. So it directly sends this data to the ESP32 module, and thereafter it sends to the Firebase database. Then the question is, what is this? This is the transistor module. This module is designed. We have personally designed this module to pass the stable current to the entire system. Also, there is one kill switch we have implemented. So if we turn on, the entire circuit gets turned on, and if we turn off, the entire circuit is turned off. So this is the implementation of the project.
Hello all. So let's move on to our app interface. So this is our app interface. After logging in, the user lands on this home dashboard. This shows the key health status indicators such as fall risk alerts, daily activity highlights. It's designed with a simple layout and large icon for elderly friendly usability. There are various screens such as exercise encouragement. In this exercise encouragement section, we have added the feature with embedded videos for the elderly people to do their daily exercise. This is the exercise video which can elderly person watch and perform their daily exercise activities, and these are carefully selected to promote mobility and reduce fall risks. Next up, we have the medical history screen. In the medical history screen, user can add its medical history, which is very informable to them. In the medical history screen, user can add or view their medical history section. This can help to track the condition and ensure caregiver have quick access to the vital info of its user. Next up, we have the caregiver panel. In the caregiver panel, the caregiver section lets family member monitor the health alerts and status remotely. In future, the caregiver can view the user's mobility through this function. So this is easy, accessible, and reliable app.
Now we will show you the live demo of our product. Here, as you can see in the app interface of the user as well as the caregiver's mobile, the alert is shown as no fault detected. when the person is sitting, standing, or walking on the street and doing day-to-day activity. As you can see, the person is fallen and you can hear the buzzer. So the mobile interface is showing that the fall is detected and red color alert. Also, the location of the person is displayed on the screen. SMS is sent to the caregiver's mobile. When the person is conscious and has no effect of the fall, then the fallen person can turn off the power button on the device.